All right, welcome back to Elements of Calculus 2. We are looking at our problem inventory. This is problem number 2. And we have, suppose that we have the cost of manufacturing a camera is going to be approximated by L of xy is equal to 3 halves x squared plus y squared minus 2x minus 4y minus 2xy plus 72. We'll figure out what's going on with this. X is the number of skilled labor hours, Y is the number of hours of semi-skilled labor, and we're going to try to figure out X and Y such that we're going to minimize the labor cost and then, yeah, figure that out. Okay, so let's go ahead and get rid of some of this stuff. Okay, let me get rid of this. Okay, so the first job I think I have here is let's take a partial derivative. So I'm just going to say Lx. That's going to be our partial derivative with respect to x, to L rather. So we're going to have, this is going to be 3x. Taking the partial derivative with y is going to be 0, minus 2 for my x. Taking partial derivative with respect to y is 0, and we have a minus 2y, and then we're going to set everything equal to 0. All right. Now we're going to have our Ly, and we're going to say derivative with respect to x is 0. We have a 2y. Okay, this guy is 0. We have a minus 4, and then we have a minus 2x set equal to 0. So let's clean this up a little bit so we could say something like this is 3x minus 2y. And I'm going to take this negative 2 and I'm going to push it to the other side of the equation to give me a positive 2. We're going to have a negative 2x here, okay, plus a 2y. And I'm going to take this 4 and push it off to the other side. So we have something like that. Because I really want to I really want to have my variables lined up because I've got two equations, two unknowns. And boy, oh boy, did this one not come out of a textbook or what? Because these are nice and easy to go from here. So all we have to do is add these together. 3x minus 2x is just going to be x. 2 plus 4 is going to give me 6. And that is my value for this first thought here. In order to figure out what my y is, pick one of the other two equations, pick one of the other equations, and go ahead and put x in and solve for y. So I'll pick this equation. That's fine. So we have, I'm going to divide everybody by 2 first here. So I have a negative x plus y is equal to 2. I just divided everything by 2 before I did anything. We said this is negative 6. So I bring in the 6 plus y is equal to 2. Go ahead and add the 6 to both sides, and we end up with y is equal to 8. All right. So we have that as a thought. Okay, so we have our little ordered pair, x equals 6, y is equal to 8. Now, we don't know what's a minimum yet because it's a second, it's a partial derivative. It's two variables. So what we really need to do is we need to get what is our second derivative with respect to x, and we need our second derivative with respect to y, and we also need Lxy. Okay, so let's see what we're going to do from there. So I've got my first derivative with respect to x, and we'll go ahead and take this first derivative. So we have 3x minus 2, 2y is equal to 2. Okay, when I take the derivative with respect to x here, again, we just get a 3. Everything else tends to be 0. Okay, when I look at my derivative of y and I take my second derivative with respect to y here, it looks like I'm just going to get 2. Okay, so Lyy is 2. Now I want Lxy. So we're going to look at our first derivative. This is 3x minus 2 minus 2y is equal to 0. We're going to take this derivative with respect to y. So that's going to be 0. That's going to be 0. And it looks like we have a negative 2 here. I'm going to look at the other one because Lxy and Lyx should be the same. Okay, in this book, in almost every partial derivative you're going to be dealing with, the partial derivative of xy is equal to the partial derivative of yx, and that's fine. This is not always true, but there aren't any problems where this isn't true in your book. Okay, but this is not an absolute rule. It's just going to happen more often than not. All right, so realize like if there's ever a true false question where you ask, is this true? The answer is false. It's not. But for all intents and purposes for your class, this is true And it's true for for PChem. It's true for almost every class you're going to take after that. There's a couple of weird places in math where this is not true, but these are places where they generally you don't usually deal with that in chemistry or engineering or biological systems. Like it just doesn't happen. Okay, but be on the lookout for it because someday you never know where you might get some kind of a weird thing. And that's just, it's not continuous when you go from different directions. That's all you're looking for. So if it's not continuous for different directions. So something to look out for. Might not be true, but for the most time it is. So what do we figure out? We did x, y. I want to do yx. So my derivative of ly, and I'm going to take this derivative with respect to x, and look at that. I get -2. Either way, it's -2. It's the same as this way. So we did confirm that this was in fact true in this case. So very good. It usually will be. It's also kind of a little idea of like what happens if bad things go wrong. The LXX and the LYY are constants. They're both twos. Well, one's 3, one's 2. The LXY is -2. So what we're going to do next is we're going to say, okay, we need LXX times LYY minus LXY um, squared. We have to evaluate what's going on with that. So we have 3 times 2 minus -2 squared. So we have 6 minus 2 squared is going to be 4. We end up with a 2 here. Okay, so my D value here is equal to 2. Okay, that's a thing you have to kind of deal with. You will have this formula on your test. Do not memorize this formula, but we'll go all the way down to the bottom here and kind of look at like, what does this thing look like? Okay, and my D is going to be greater than 0 because it was 2. So my D is greater than 0. I'm going to look at this column right here. And then what is my FXX? My LXX in this case, my LXX was 3. So my LXX is greater than 0. This, in fact, is a minimum. So yes, this is a minimum. Okay, and that is when X was equal to, what did we find out? 6 and Y was equal to 8. Um, X equals 6, Y is equal to 8. What is the labor cost when we go all the way the heck back up here? We can go ahead and write down the original formula again and plug this in. So I have 3 halves x squared. Okay, so we have 3 halves x squared plus y squared. Let's go ahead and have a look at what's going on there. Um, Plus y squared minus 2x minus 4y minus 2x minus 4y. Okay. And then what do we have here? Minus 2xy. Minus 2xy. And then we added something to this, didn't we? Plus 72. Okay. And you guys are allowed to use a calculator for this. But what we're going to do is plug in the values for this. So we have 3 halves times 6 squared, which I'm just going to say is 36. I'm not going to worry about trying to, if I could do the arithmetic in my head for a little bit, I will. Times 36 plus 8 squared is going to be 64 minus 2 times 6 minus 12, 4 times y, so that's going to be minus 32. Okay, minus 2 times 6 times 8 plus 72. And at that point, I'm going to say, I'm going to cry uncle. And I'm going to go ahead and grab my little calculator here because I don't need a big calculator for this kind of a problem. This is just fine. So we're just going to go ahead and type in 3 halves, which is 1.5 times 36 plus 64. Okay. Um, Minus 12 minus 32. Let's see. 6 times 8 is 48. 48 times 2 should be something like 96. So we have minus 96, and then we're going to add 72 to the whole thing, and we got a value of 410. Okay, so that is what something like that would look like. Um, be careful when you're plugging the things in and make sure you do the correct arithmetic on that. But that's pretty much what you're doing with all of that. Um, let's see. Oh, I don't have it anymore. Okay. But I trust you guys are actually going to be better at doing this than I am. So in any case, I'm going to stop our video there, and I'll say thank you very much for watching the video. Good luck studying with everything, and I wish you the best on the exam.